talking about the moon and how it could be a launch pad for exploring the greater solar system, I genuinely think long-term, and I do mean long-term here, over the next couple hundred, maybe even 1,000 years, the moon could grow to be an absolute economic powerhouse. And I genuinely think it could even rival the Earth itself.
I could completely agree with that.
Hello and welcome to Entropy Rising, where we talk about science and futurism. I'm your host, Jacob, and as always, I am joined by my wonderful co-host, Lucas. Lucas, how are you doing today?
Never been better, Jake. How are you?
I'm doing great. Never been better. Wow, that's a strong claim. Well, it's because we've just finished recording our 10th episode, I think.
Yeah, absolutely. I mean, I'm ecstatic.
Yeah. So today we're talking about a topic a little more close to home, which is colonizing the moon and how we're going to expand onto the moon and live on the moon. And I think it's going to be quite an interesting discussion for us today.
Yeah, absolutely. I think so. There's a lot of potential with the moon.
Oh, yeah, absolutely. I mean, it's hugely advantageous. So, the moon has the distinct honor of being the only celestial body that humanity has so far ever stepped foot on.
Yeah. That's definitely very cool, even though we were only there for a little while and we already had a speech planned for our astronauts coming back or not coming back.
That is true. I forgot about that. It's such an interesting piece of history. But yeah, so we have been to the moon. It's been a while, of course, and we haven't gone back. And so I do want to say that when we're talking about, in this episode, going to the moon, it really doesn't make sense to do any type of Apollo-style mission, showing up for a couple of days and grabbing more moon rocks. It was really good to do in the 50s because we learned a lot from those samples we got. But today, we could send robots to go collect more samples if we really needed them.
Yeah.
And while having some more of those samples would definitely be nice for science, I don't really think the cost benefit is there doing a couple day missions on the moon.
Absolutely not. It's good that we have those samples, that we can see that there's no microlife up there that's going to kill us if we take our spacesuits off. But other than that, it's mostly the same stuff that we have down here.
Yeah, exactly. So when we talk about going to the moon, we really are talking about going to the moon and developing some sort of permanent settlement.
Yeah, going up there and being able to actually build a foundation would be a really incredible step forward for humanity.
I absolutely agree. That's why we talk about colonizing the moon. There are so many advantages to the moon. One of the ones being that the moon is very close to us. It's only a 3-day trip away. At least with the orbit that the Apollo mission used. You can get there faster, of course, if you're willing to expend more fuel, but it's very close to us.
Really? Only 3 days?
Yeah.
I don't know why I thought it was further away.
It is a far distance when you think about it. Was it 350,000 miles, I think, off the top of my head?
So that's a lot of distance.
It is. You can actually put every planet in the solar system between Earth and the moon.
Wow. But we can get there in 3 days.
Yeah, about 3 days at least. That's with the orbit that the Apollo missions did. You, of course, like I said, can get there faster at the expense of fuel. And maybe when we have permanent colonization and we can refill ships in orbit, you might choose to go faster at the expense of fuel, if you can get that fuel from space.
Of course.
Yeah. So the moon being so close makes it one of the most accessible places off-world for us to build a colony. And it has the distinct advantage of being so close to Earth that if something did go wrong, launching a rescue mission is much easier than, say, Mars, for example, right?
Yeah, absolutely. The moon would essentially be Earth's truck stop, right, on the way to our solar system.
Yeah, no, exactly. I like that analogy of a truck stop because when we're talking about colonizing the moon or why we would build a base on the moon, obviously mineral extraction is a big one. There are some minerals to be gained on the moon. But really, one of the best advantages the moon has is refueling station for ships because it costs so much fuel to get off of Earth and into Earth's orbit that you really don't want to carry more than you need. So if we could carry just enough fuel to get off of the Earth and then refuel once we're in orbit, that saves you a ton of mass versus having to carry all the fuel you need to get to Mars, for example, from a launch pad on Earth.
Absolutely. Yeah. It makes such a huge difference.
Yeah, so when we talk about why the moon, that's one of the biggest reasons. If we can get a base set up on the moon that can harvest something like water ice, you can take that, break it into its constituent components, oxygen, hydrogen, and then that's one of the most popular rocket fuels you have, just hydrogen and oxygen.
Yeah. And it wouldn't make sense if we couldn't make the fuel on the moon. Because if we had to transport the fuel up to the moon to then give to the ships, then you're burning all that fuel to get there anyways.
Exactly. So, when we talk about having a refueling station, you are right. We have to be able to get that fuel on the moon.
Yes.
Thankfully, though, like I said, hydrogen is one of the most common rocket fuels we use. second only, I think, to methane. But you can also even make methane on the moon. It's only carbon with some hydrogens. So as long as you have a source of carbon on the moon, which there is definitely carbon on the moon, there's carbon compounds, you can also take those and make methane too if you did want to use a methane fuel.
Yeah. Or space cows.
Space cows.
Mm-hmm. You do some animal husbandry on the moon. Cows produce a lot of methane.
I see. I don't know about the economics of raising cows on the moon, because they definitely need some inputs as well. I think maybe chemically making the methane, but that doesn't taste as good. You don't get some steaks out of it. There goes all of our vegetarian audience.
No, we're not eating them. We're using them for their gas.
But yeah, so you can definitely make methane on the moon because you can use that for rocket fuel. But I think just simple hydrogen and oxygen makes the most sense because that's already something that we use for rocket fuel. And it's one of the best rocket fuels there are, really.
Absolutely.
Of course, that brings us into one of the moon's largest advantages and sometimes a disadvantage, depending on what way you're looking at it, which is the moon's gravity. It only has 1/6 the gravity of Earth, which means that if you have some kind of base on the moon where you're refining fuel, it's not hard to get it into orbit.
Yeah. Being able to manipulate things without expending as much energy will always be a big advantage.
Yeah, exactly. So being able to get stuff off the surface of the moon into lunar orbit, or even from lunar orbit to Earth orbit, is so much easier than it is to get something from Earth into Earth's orbit.
Yeah. It's like getting stuff out of Earth's orbit is like next to impossible, which is why all of our ships are 90% fuel. If our gravity was just a little bit heavier on Earth, we wouldn't even be able to leave.
Yeah, exactly. So the fact that the moon has no atmosphere and it only has 1/6 of Earth's gravity makes it a great almost truck stop, like what you were saying, for refueling or also for mineral extraction. Mm-hmm. I think, was it our first episode or maybe our second? I think it was our second episode. We were talking about mining asteroids, but we can also mine the moon. I think it's easy to forget, but the moon has more mass than the entire asteroid belt combined. If you look at it at night, it's covered in craters, right? All of those craters came from asteroid impacts. And in the middle of those craters are all of those precious metals left by the asteroids.
I see. Now that's pretty excellent, actually. And it's already like pre-mined.
Yeah, exactly.
It's been done for you.
Yeah. So, we already have had a couple of probes go around the moon, do some spectral analysis to try to determine the composition. You got to think, especially once money's involved, building probes like that, scanning it, identifying craters that have high concentrations of precious metals, mining them, and then the moon's low gravity and no atmosphere makes mining those materials and getting them back to Earth. Or alternatively, just using those materials on moon to build and develop ships for space or other orbital infrastructure.
I feel like that's much better, not just building up the moon, but like you said, building up an orbital infrastructure, starting on our first O'Neill cylinders and on different like ships that can be sent out to travel to further planets or even to other star systems.
I absolutely agree with that. And one of the things that is good about the moon is that it does still have gravity. We talk about zero-G manufacturing or any type of orbital manufacturing all the time and all of the advantages it has. And there are many advantages, but sometimes you do really want gravity. Some processes will do better with gravity. So the moon's a great option for those processes. 1/6 gravity, you get the benefits of low gravity, being able to move heavier things around with less effort, and getting them off the moon is a lot easier because of that gravity. Mm-hmm. But you do still have a little bit of gravity to help make things easier along the way.
Absolutely. And zero-G stuff could be complicated just because the slightest bump or nudge, it causes it to manipulate itself if it isn't latched in.
That and trying to work with any type of fluids like metal casting, all of that in zero-G really does become a problem. So the ability to have some gravity to aid with those manufacturing processes while not being in such a deep gravity well as Earth is a huge advantage for the moon. And I would not be surprised if lunar orbit became one of our biggest places for building spaceships or O'Neill cylinders, just because you can manufacture things on the moon and very easily launch them up into lunar orbit.
Yeah, absolutely. Also, because of the moon's lower gravity, and with all that manufacturing that we're going to be doing, we need a way to get those resources quickly to the areas that we need them manufactured. A lot of people, they'll talk about space elevators, which is more feasible on the moon.
Absolutely.
Right? On Earth, it's next to impossible. But on the moon, it is very possible. But I think that space catapults would be one of the more efficient ways of doing it. Having something that's almost like a railgun system or like even a series of small explosions to launch a pod that would then be caught by another mechanism, either on a station that's building ships or another place that needs those resources. And it can just catch it and grab it. And it would be incredibly efficient for us to transport resources that way because it's using all just kinetic energy once the mass is launched.
I particularly like the idea of using like an electromagnetic launching system to accelerate pods, like you were saying, fast enough to get off the surface of the moon. Something I also really like about this is you can have separate types of launchers for different material.
Oh, yeah.
So if you're launching something like raw materials, like metals, ores, you can launch those at much higher G and have a shorter track and just have them launch at 10G or something like that. But if you're trying to launch sensitive components or maybe humans, you can do a much larger track, a more gradual acceleration. So you can really just customize it to be whatever you want it to be.
Yeah, whatever it needs to be.
Exactly. Yeah. And that's really not something you can do on Earth. There are a couple of companies, spin launch systems is one of the most popular. You could never really put a human through that.
It would be like scrambling an egg.
Yeah.
It would be good.
It would absolutely not be pretty. So when we're talking about launching off of the moon, you don't even need to do chemical rockets. You can just literally fling things off of the surface of the moon, and that works wonderfully for our moon.
Oh, yeah. Yeah. And that's really why it would be such an amazing depot.
Yeah,
like
exactly.
A hub for sending materials out.
But that's not to say that the moon isn't going to have some issues, because of course, living on any body that's not Earth, we're not going to be adapted to that. And that is going to create issues. And I spoke earlier, I said one of the moon's biggest advantages and disadvantages was its gravity. So when we're talking about getting material off of the moon, great. Low gravity works perfect for us. When we're talking about living on the moon as humans, low gravity becomes an issue.
Yeah, there's definitely a few things to take into account. Just pulling from examples of astronauts that spend a lot of time on the ISS, they struggle with issues like bone density, muscle atrophy, elongation of vertebrae, and then when they come back into Earth, it compresses and pinches nerves, things like that.
Yeah, exactly. And I mean, these are people who were born on Earth and only spent, I don't know what the longest mission is, I think, a year, maybe 2 on the ISS. And they already had all these issues. So we have no idea what's going to happen with longer term missions than that, or with people who were born in low gravity.
If you never have to go back to Earth, I wouldn't mind being a few inches taller.
Yeah, that's true. But man, it really does suck to lock yourself off of Earth forever.
Yeah, but maybe it won't at one point, right? Like from a lot of the science fiction that we read, they create a culture and a life, like the Outer Rim and the Expanse. It's a totally different culture and way that they live there, and they don't even want to go back to Earth.
That is true. And it is also worth pointing out that we don't actually know what the effects of low gravity are on humans or even our development. We can really only extrapolate from the little bit of data we have on how humans do at 0G, which is not very good.
Yeah.
And then the absolute massive amount of data we have on how humans do at 1G. Those are the only data points we really have. So we don't know how much gravity humans need. It could be the case that lunar gravity is more than enough for humans and there's no developmental issues and the bone loss issue and the atrophy issues don't exist or are very easily mitigated. Or it could be the case that 90% of Earth gravity isn't enough and we run into the same issues there. So unfortunately, when we're talking about bone loss and low gravity effects or how that affects humans, we really are just guessing.
Yeah, no, I definitely get that. It could even have good effects on us. Because you think about different therapies that people use in like water, for example, water therapies, water sports. A lot of people find relief from pain or even feel stronger after doing things like that.
Yeah, I think realistically what we're going to find when we talk about humans developing and living in low gravity is it's going to be a mixed bag. There are going to be some things that are bad for our health and then some things that are good. I could definitely, like you were saying, see low gravity being really good for reducing things like arthritis for maybe, or back problems. But I also think it is going to have some issues, on our circulatory system and some other things. Will the bad outweigh the good? I assume there's a certain gravity where that happens.
Oh, yeah, absolutely.
My personal guess is that the moon's gravity is probably too low for humans. I don't think it's going to be catastrophic for our health, but I do think there will be issues there. I feel like maybe 75 to 80% of Earth's gravity is probably going to be like a really nice sweet spot where we don't have any issues. But like I said, that's really just a guess. We don't know yet.
Yeah, that definitely makes sense. But honestly, I feel like gravity is probably going to be one of the least of our worries when we're on the moon.
Oh, really?
Yeah, mostly talking about just the environment of the moon in general.
Okay, yeah, that's fair.
So like moon dust, for example, is very damaging. It's statically charged, so it's going to stick to everything, and it's not worn down, so it's very abrasive.
That is true. Unlike, well, one of the advantages we talked about earlier was the moon had no atmosphere, no weather. It's a disadvantage here because now you have all this really sharp dust that hasn't been worn down like it is on Earth.
Yeah, and it not only sticks to like people, but it sticks to your habitats, sticks to your robotics, and clogs everything up. It can cause a lot of damage.
Yeah, it can do a lot of biological damage too. The moon's regolith is mostly made of like silicates, and those are really damaging for your lungs if inhaled. So if you're tracking these into your habitats off of the lunar surface, especially over a long period of time, you're basically like breathing something similar to asbestos constantly.
Yeah, which is why you would need, like you see in the movies or in books, a decontamination chamber where you get sprayed down, all your suits get sprayed down and everything, and then you have to take them off.
I like the more modern approach that we're starting to see of the spacesuits that never actually enter the chamber. They like attach to the outside and you climb into them. That way you never actually have crossing over. Yeah.
Oh, man. No, that's cool. How do you get your chute?
The back of the suit is a hatch. So when you're ready to get into the habitat, you just back up into it and it locks in and you climb out of the back and then the whole suit just hangs onto the outer wall of the habitat.
Interesting.
And you just like slide in and slide out. It's one of the prototypes they've been testing for Mars rovers because Mars also has an issue of the regolith is very damaging. It's got a lot of perchlorates, which are really bad for you. So you don't want to have to track in and out those, especially on a rover where you don't have room to do a proper decontamination. So yeah, it's a good way to keep the interior and exterior completely separate and maybe just have a small chamber for passing through samples.
Yeah, absolutely. And that's something that we're already looking to put into practice.
Yeah, there's already been prototypes, of course, tested on Earth and not Mars, but there's already been prototypes of these. I think NASA has a rover design already like this, where the spacesuits just clip onto the back. And like I said, the astronauts can just climb in and climb out of them.
Wow. Yeah, that's awesome. Talking about these spacesuits for a second, we need a way that we're going to be able to work in these environments because the moon is tidally locked.
Yes.
And it's going to experience very drastic, not weather, like you said, but temperature.
Yeah.
Big drops, very cold on the dark side, very hot on the warmer side of the moon. But people are going to have to work outside of that in those temperatures regardless. Do we have the technology for these spacesuits to be able to do that yet?
Yeah, absolutely. That's something that spacesuits today already face. The ones that we use in the ISS, for example, when they're exposed to the sun, it's really hot. When they're shaded by the Earth, it's really cold. And, we went to the moon back in the Apollo days. Those spacesuits were also designed to provide insulation when the moon was on the light side. I don't think we launched any Apollo missions on the dark side of the moon or in the moon's shadow. I could be wrong about that, but I don't think we did. So yeah, even with current technology or even technology from the 50s and 60s, yeah, we can definitely design suits that can handle the lunar day-night cycle.
Okay. Yeah, I just wasn't sure if they could handle it for those extended periods of time, but it would make sense that they could.
Yeah. Now, actually, one of the bigger issues with that isn't going to be the suits really, but it's also going to be the habitat you build, right? Because like you said, these are going to be exposed, I think it's like a 300-degree temperature swing between the lunar day and the lunar night.
Yeah, give or take, 300 degrees up or down.
So, when you're talking about building habitats here, that's a pretty large thermal swing they're going to have to be able to handle. And that's going to be a lot of expansion and contraction. So that's something you're going to have to engineer for. It is almost an advantage that the lunar day is so long because it takes the moon 1 month to go through a full day-night cycle. So 2 weeks a day, 2 weeks a night. So there's a large swing from cold to hot, but you're only experiencing it once a month. So the actual thermal cycling, which is what does the most damage, is relatively limited compared to like Earth, where day and night are 24-hour cycles.
Yeah.
Granted, we don't have that extreme of a temperature swing. So,
I mean, honestly, with it being so long, you could even put like special habitat reinforcements in place for those different cycles. Like it's the same way when you put like a water canopy over your tent. You could have something similar that you could put over your habitats, like that could enclose them in, that could protect better from one way, then increase the efficiency of the habitat on a different type of cycle. If that makes sense.
Are you talking about like maybe doing some kind of solar shade that can be deployed during the day? Or maybe you could even do like orbital mirrors to shine light into your habitats during the lunar night.
Exactly. Something that could make it more livable or more efficient or both.
Yeah, I could definitely see us doing something like that. I think realistically, when we're talking about building a colony on the moon, I don't think we're going to be living on the surface of the moon in domes, or if we do live on the surface in the domes, it's probably going to be smaller domes and realistically probably located in craters. Another option is we can also colonize lava tubes on the moon, which are essentially these giant tubes that are left over from when the moon used to be tectonically active.
Okay.
And sometimes you get something called a skylight, which is where when these are very close to the surface of the moon, they collapse. So we could potentially use these skylights to gain access to lava tubes and then build out some of our first colonies there, which has a huge advantage because we get protected from these temperature swings like what you were talking about. Also protected from like micrometeorites and some of the radiation that the moon gets exposed to.
Yeah. And because we're going through, like you were saying, holes in the tops of these tubes, we could still get natural light to come in to grow crops or whatever we needed from that UV light.
Absolutely. And you can even intensify it with orbital mirrors if you wanted to, or you don't even really need orbital mirrors. You could put mirrors on the surface of the moon, redirecting the light into that tube, using that just as free energy to power grow lights, or just put solar collectors, of course, and power internal lighting.
Okay. Yeah. I mean, that definitely sounds like a good option. It, of course, comes with some drawbacks, like living underground is never easy.
That is true. Humans naturally, I think, prefer wide open environments. So I do think there would be some psychological issues, or maybe not issues, but there would be some psychological stress to living in these confined areas where you never see the sky.
Yeah.
To be fair, though, I don't know what would be worse psychologically, being in an enclosed environment like a lava tube or being in like a dome where you're seeing the vacuum.
Where it's like at any point a meteorite the size of a nickel could come in and just kill you and your family. No, I understand.
So yeah, I don't know what would be
I
worse.
would probably prefer underground.
Yeah, exactly. That's why when we talk about building any type of dome structure, we're not ever, I think, going to build any massive dome where we have hundreds of thousands to millions of people living in. If we do go for any type of domes, they're probably going to be A, in craters, and B, a bunch of smaller domes that are connected with pressure doors ready to seal off in the event of a crack.
Yeah, absolutely.
Speaking of building these potential dome structures or anything, I mentioned we could build them in craters, and I do think that's a really likely place for us to build any type of moon colony.
And why is that?
Craters have all kinds of advantages. One of the biggest ones is when they form, you get a crater wall that actually sticks up over the top of the moon. So if you imagine you're on the moon's surface, to go down into a crater, you first go up.
Okay.
Yeah, because when it hits, it builds like a mound all around.
Right.
That's really convenient because if you can get up higher, you can put solar collectors up higher and extend the amount of time that you're collecting solar power during the lunar day. And because the moon day-night cycle is so long, even getting a couple of 100 feet above the surface, on Earth, that might buy you a couple extra minutes of daylight. On the moon, that could buy you like hours and hours, maybe even a day of daylight. So it's a pretty big difference when you're talking about solar power.
So these crater walls are actually pretty massive.
Yeah, some of these craters are absolutely huge. And then another advantage that these craters have is that especially the polar craters, there are some sections of these craters that never get exposed to sunlight. And that's where we think a lot of this water ice exists. So that's going to be a natural resource deposit that we're going to want to harvest anyways. So setting up a colony in a crater where this water ice could exist, in the center of this crater, you're provided potentially with shelter from the lunar day. So you could build a colony and be protected from micrometeorites and also be protected from radiation and extreme temperature swings, all while having this giant crater wall that provides you with a good place to collect solar energy.
Yeah, absolutely. So when we're talking about the ice on the moon, and we need to get resources essentially for these habitats to sustain for people. So we need water.
Yeah.
Living up in the North Pole of the moon, we need to figure out a way to collect that ice and transport it to the people that need it, right? And I feel like it would be difficult living on the poles of the moon where they don't see any sunlight.
Well, the poles on the moon work similar to the poles on the Earth. The moon has an orbital tilt relative to Earth, and it has an orbital tilt relative to the sun. So just like how on the Earth you get these really long day-night cycles, you get that to an extent on the moon as well. But I don't really think that's as much of an issue because it's not like you're outside anyways. And even if you live on the equator of the moon, you have to account for really long 2-week days, 2-week nights. So I don't think there's an issue with having a colony built on the polar regions of the moon. I think it could actually be a huge advantage because you could build your colony in the shaded region of some of these craters and you don't have to ever account for the lunar day. And again, building your colony where the water ice is gets rid of that transporting problem.
Yeah, which would be a huge problem. And now that I'm thinking about it, it really does make sense because it would be much more efficient to build energy collection stations further from the outpost and then be closer to the physical objects that you're trying to move, like ice.
Yeah, exactly. And I will say one of the only issues I do foresee with being in the polar regions of the moon is getting into orbit. Naturally, if you're in the polar region, if you try to launch into orbit, all of your orbits are going to be polar orbits, which are not hugely advantageous. So you would have to expend energy changing those orbits to line up with the Earth-Moon ecliptic plane, especially if you were trying to do a transfer to Earth. Or if you did transfer to Earth, you would end up in a highly polar orbit around Earth, which maybe isn't an issue. So there could potentially be some extra energy expenditure adjusting orbits from polar regions. But other than that, I think the polar region of the moon makes a lot of sense.
Yeah, it's definitely a good point. But I feel like once we're getting to the point where we are launching things from the moon, it's not just going to be, we're on the poles. Maybe we start there.
Yeah.
But by the time that we're launching things from the moon, we could have launch pads all over the moon.
That's true. Although I do think that we will probably be launching things off the moon from day one. I imagine the first moon base even is going to try to achieve some sort of economic output. So the only way you're going to be able to do that is to mine materials from the moon and launch them to Earth, or mine materials from the moon and get them into orbit for some type of larger solar system exploration.
Now, that it does make sense, because when we think of old mining towns, they pop up almost instantly, and then the miners are immediately mining while the rest of the family's already trying to just set up a place to live in an economy. So it could be like that. I just feel like once we get to the moon, it being such an alien experience, we need to have that base infrastructure of knowing that our people can survive. Mm-hmm. Knowing the toll that the moon will take with its gravity and its radiation and its dust particles, things like that. And then once we know that it's a actual survivable and thrivable area for us as humans, then we start building the infrastructure for progression and income.
Yeah, I think a lot of those questions will be answered in some of the first moon bases, which are probably not going to be where you're going to have any family or anything like that. These will probably be completely industrial outposts, almost like oil rigs here on Earth. Very extreme environments, very unsafe for families. Really only somewhere that you're going to go to work a shift, potentially get a lot of money doing that. You're accepting a lot of these risks because there are going to be a lot of unknowns with the first base. I'm assuming you'll be adequately compensated for that. Mm-hmm. Granted, I think a lot of people would jump at the option of living on the moon or visiting the moon, even if the compensation wasn't that great, just for the experience of it.
I'd go.
That'd be pretty prestigious, right? Yeah. So yeah, these first colonies are probably going to answer a lot of those safety questions that you're bringing up now. And I'm sure we are going to learn a lot from these first colonies.
Yeah.
At the expense of people. You know, there is a real risk in doing this. I think it would be naive to believe that we can colonize our moon without losing anyone along the way.
Yeah, I mean, well, people die in accidents here on Earth all the time.
And this is a lot safer than going to the moon. So that is going to be a risk. That is something that we're going to try to mitigate. But it is a genuine concern, a genuine risk, and something that I think people are just going to have to face if they opt to go for this route.
Yeah, absolutely. Regardless of that, though, they will still need a sustaining infrastructure set up.
Absolutely, because any of the advantages that you have on the moon start to get lost if you need to ship material from Earth to sustain this colony, which you will 100% have to do in the beginning. But yeah, so I think we are going to have to send up some resources to get the lunar base kickstarted. Mm-hmm. You know, the moon has a poor source of nitrogen, and nitrogen is really important for agriculture. So perhaps sending things up like nitrogen and all of that to kickstart hydroponic farming could be really important in the early days. But hopefully over time, we can start to build a self-sustaining base on the moon, and we can start to rely on shipments from Earth less and less, or potentially make up for any of the moon's deficiencies by going to the outer solar system, capturing resources there, bringing them in, and using that to sustain the moon. But when we're talking about building a base on the moon, one of the biggest advantages of the moon, or something that we see a lot in science fiction, is this idea of harvesting helium-3 from the moon to power fusion reactions.
Now, that would be incredible, because helium-3, like we've touched on before, is one of the most is the most efficient fusion reaction that you can have.
Yeah, the efficiency is definitely a big thing with helium-3 fusion, because all of the particles produced, at least in an ideal reaction, are charged, and it's a lot easier to capture the energy from charged particles. Also, since there's no neutrons emitted, theoretically, you don't run into as many radiation issues. So yeah, if we could capture helium-3, and if we could ever figure out how to do helium-3 fusion, the moon would be a great source for that. Now, the downside of helium-3 on the moon is that it's spread out all over the surface. It's not in any like dense pockets, because helium-3 exists on the moon only from being exposed by the solar winds.
Right.
They hit the moon and stay there, so there's no concentrations of it. So instead, if you want to gather helium-3 from the moon, you're going to have to build some sort of rover that goes and scrapes up the surface, processes it, gets the helium-3 out of it, and then redeposits all the regolith behind it.
Well, it's a good thing too, though, because that machine, while it's doing that, it could also pick up all that corrosive dust that we were talking about and sort of tumble it a little bit.
Oh,
You
like
know,
a rock tumbler.
yeah, make it a little bit less abrasive
Oh my
while
gosh.
collecting helium. It would be similar to farming than it would be to mining.
Yeah, it would be almost like, when you see these like big excavators going and like pulling up the surface, the topsoil, and turning it over. It could be something like that, just on a much larger scale.
Yeah.
Yeah, that'd be interesting.
Yeah, but I think that acquiring that helium-3 and using it for fusion reactors on the moon, because assuming at this point we do have that technology, we would just need one for the start of it.
Oh yeah,
and,
for the start.
And that could power everything without us having to use all of this valuable room that we've found for this perfect spot for a colony on solar panels.
Yeah. Yeah, I agree. Although I think if we're building in a crater, I think lining the rim of that crater with reflectors even to reflect light into it, to light it up, and then collecting power through that could also be a viable option.
Oh yeah, absolutely. Being able to manipulate light like that and
is huge, yeah.
Send it into like crops or point it at ice shelves to melt them, things like that. Very important.
Although you don't really want to melt the ice on the surface of the moon because then it's just going to sublimate. Hard to collect it then.
Yeah, that is true.
Talking about the moon and how it could be a launch pad for exploring the greater solar system, I genuinely think long term, and I do mean long term here, over the next couple hundred, maybe even 1,000 years, the moon could grow to be an absolute economic powerhouse. And I genuinely think it could even rival the Earth itself.
I could completely agree with that, especially if it's taken over by corporations and it is the one-stop place where you launch everything into the greater solar system. That makes complete sense.
Absolutely. I mean, because when you think about it, the Earth, of course, is going to be, I think, one of the largest industrial centers of human civilization for the foreseeable future. It's going to take a very long time for a colony to surpass that. But the Earth has this huge disadvantage of being locked on a really strong gravity well and having a relatively thick atmosphere, which means achieving orbit from Earth is a huge challenge. The moon, however, has that advantage of, like you were saying, being very close to the Earth so it can tap into the Earth's resources or even just be a staging ground, because I think we mentioned earlier in the episode, if you do launch anything off of Earth, you don't want to have to carry any more fuel than is necessary. So you're not going to launch anything off of Earth straight to Mars if you have a moon base. Yeah. You're only going to launch things off of Earth into Earth-Moon orbit and then refuel it at the moon. So the moon politically could have a humongous advantage over Earth. You even see in some science fiction books where the moon is the seat of government power in a fully colonized solar system just because of its position over Earth.
Oh, yeah, absolutely. There are a few things that also could tilt in the other direction. Like the moon, if its economy is completely based on industrializing our solar system, then it will lack amenities and the production of fine goods, things like that, which a lot of people spend a lot of money on, and that could supplement Earth's economy even more, making it a larger powerhouse. But
I don't know. I think it would work more like a really rich port city, because anything between Earth and the outer solar system is flowing through the moon, which gets at a lot of money. And I think you could see a lot of wealthy merchant type people there who do enjoy the finer things in life. And it being this import-export hub, almost like I was saying, a wealthy port city from antiquity. I don't know. I think the exact opposite. All the amenities might be on the moon.
It definitely could be. And it would be nicer because it's way easier to send them to Earth than it is to send from Earth to the moon.
Yeah, exactly.
But some things they might just not be able to fit or create there. And then they're going to be paying top dollar for Earth to send them those things.
That's true for anything coming from Earth. Getting anything up Earth's gravity well is a huge struggle. So,
like nitrogen-rich dirt could become one of the most valuable commodities coming from Earth.
I could definitely see that. Organics in general. There's all kinds of things. Anything coming from Earth is going to be a huge luxury. I think I went down like a rabbit hole looking what could be luxuries of the future. People were talking about things like wood, because wood is actually pretty hard you can't really artificially make it. You got to grow a tree, and it's really space intensive, so it's hard to do that in some orbital habitats.
Yeah.
Something like marble's made through geologic processes, so unless we find a way to replicate that, then that's going to be a huge luxury item, and it's insanely heavy, so transporting into orbit, only the wealthiest of the wealthy would do that. So yeah, I could definitely things like that. The moon's going to have access to those before the greater solar system. If you've got marble on orbital base in like Saturn, that's going to be a much more status symbol.
Absolutely. Yeah. No, you're right. Once it is completely set up and we have really spread out, not just through our solar system, but to a couple of other solar systems as well, the moon may not have to produce those commodities. It simply has them from trade.
Exactly. Yeah. Yeah, so, the future of the moon is really bright, and I think it's going to play a huge role in human civilization.
Oh, yeah.
Potentially, even if we became like a Kardashev 2, maybe like a 2.5 civilization, once we have Dyson spheres and we're colonizing other solar systems, we might even look back and terraform the moon. which is a crazy thing to do, by the way. It's a horrible terraforming target. It would require a ton of energy, but it is technically possible, and that's something that we might choose to do if we had basically unlimited energy and didn't mind spending all of it on the moon.
Yeah, almost as like a tribute.
Yeah, exactly.
We'll see it as our first leap into what we are now.
It'd be crazy to do. My best guess would be increasing the mass of the moon and like black holes and then moving it further from the Earth to not destroy the Earth. So definitely not something you're doing unless you just have energy to spare. But it is one of the crazy things we could do with the moon in the long term if we really wanted to.
Yeah, definitely. I really love how usually in space, if you have a problem, you can fix it with a black hole.
Yeah, it fixes a lot of issues. I do seem to turn to those a lot, I think. Yeah. Well, I think that's about everything I have to say about moon colonization.
Yeah, I think that we definitely went over a lot. I definitely learned some stuff today.
Yeah, me too.
And I really enjoy this topic because I feel like it's something that's really achievable and is in our nearest future. And I feel like a lot of people will relate with that as well.
I see it as almost inevitable.
Yeah.
Lucas, thank you so much for being here.
Thank you for having me.
All right, everyone. Thanks for joining us. And of course, stick around for our author spotlight.
Yeah, thank you so much, guys. Bye-bye.
Bye.
In Our Likeness is a speculative novel about technology, the people who make it, the people who use it, and the way that new technology alters our relationships and our way of looking at the world. The narrator of the book, Graham Gooding, is a tech worker who's asked to test an algorithm built to identify misinformation on the internet. What he discovers in the course of testing it is that he can use the algorithm to rewrite reality itself. Graham is an everyman with a lot of problems. His mom's sick, he's got a work crush he can't seem to act on, and this is his chance to improve everything. But he struggles with the ethics of changing lives. This story is compelling and relevant because we're all grappling with constant changes in technology and new capabilities, especially when it comes to artificial intelligence. So much of modern life is lived digitally, and as a result, the very nature of how we interact, who we are, is in the process of constant adaptation and change. And In Our Likeness is a book about living through and searching for meaning in the midst of all of that.